Here we have an EVGA XC3 3090 that came in for repair. Let's read what the customer wrote. We already have the board disassembled right here. And we're going to take a look and see what's going on with the board. I dropped my EVGA 3090 XC3 with a water block on it. It landed entirely on the part that screws into the PC case. And the shear force bent the display outputs. I have not been able to identify any other part of the board with visual damage. So it looks like the card dropped and the display outputs bent. If we look at the display outputs, which we have right here, I do not see anything obvious. Let's go under the microscope and see if we have any bent pins on HDMI or DisplayPort. And I do not see anything obvious. The connectors look good. This one may look a little bit off, but I do not think it's a big deal. Let's quickly go over the card. Maybe we do a visual inspection and we measure along the way. We have two 12-volt inputs here. Let's measure to see if we have a short circuit on the 12-volt line. And we measure the 12-volt lines at those two coils or the current sense resistors. We do not have a short. And we do not have a short. And if we move down here, we do not have a short. And on top, we do not have a short. If we go all the way down to the connector, we're going to measure a 3.3 volt line. We do not have a short. And we should get a 0.4. We're getting, oh well. Oh well. Okay. So we must have a blown fuse not to read any value right here. We do not have a fuse on this side of the board. We must have one on the back. Yeah, we have one right here. If we measure from here to here, oh, fuse is blown. Okay, now the fuse is blown, but do we have a short circuit? Yesterday we worked on a video card, the 980 Ti, where we had a blown fuse and a short circuit. We do not have a short circuit. We are reading 0.490. So the fuse probably blew not because of a short circuit, but because of the drop. Something happened when the card dropped that caused the fuse to blow. I think right now it's safe to say that we can replace the fuse without looking anywhere else on the board. We do not have a short circuit, so it's safe to replace the fuse. If we had a short circuit like yesterday, then we have to diagnose further to see what's causing the short. But in our case here, we do not have a short circuit, and we can just replace the fuse. But before we replace the fuse, I'm going to do a quick visual inspection just to see if there's anything obvious. We do not know what happened when the card dropped. Maybe the HDMI cable bent, or whatever cable was plugged in bent in a way that triggered the fuse to blow. Maybe the power connectors got snatched and the fuse blew for that reason. But it's not a short circuit that caused the fuse to blow, and that's a good thing. Anytime you have a short circuit on the fuse, it means something else is wrong with the board. But since we do not have a short circuit, we can assume that we do not have a short on the board. And we already measured the 12-volt line. We measured 3.3 volts and nothing. And if we measure front of the board, I was going over back of the board, but now if you go over front of the board, and that fuse is blown also. Wow. That fuse is blown also. Oh well. So we have more than one blown fuse. Wow. And those are the 12 volt fuses. You know the 12 volt coils that we measured for a short current sense resistors right here. We went back to them, and my assumption is probably correct that the power cables got snatched out of the cord, and that caused the fuses to blow. The one on the back, the 12 volt one on the back, and this one here. Let's see, do we have a short circuit here? We already measured, but I just want to make sure. And we do not have a short circuit. So this one is blown, and the one all the way down here at the connector on back of the board is also blown. Just quick visual inspection. We're almost done. I'm going a bit fast because I know what I'm looking for, and everything looks good to me. Those are the connectors, and nothing obvious. Okay, so why don't we start by removing those blown fuses. We can use a combination of hot tweezers and hot air. The board is very thick, and hot tweezers alone is not going to cut it. A lot of thermal mass on this board. So I'm using a combination of hot tweezers at 450 degrees Celsius and hot air station at 500 degrees Celsius, maximum airspeed. That's how much heat it takes to remove a component of a video card, like this one. And let's remove the one on the back. Apply Flux, Amtech 559, and we are a distributor for the Flux. If you do not already know and you're new to the channel, we carry everything from hot air stations, soldering stations, thermal cameras, grinding pen, tweezers, flux, all the tools that we use in the shop here, we carry and sell on our website. Just log into NorthridgeFix.com. If the item is in stock, add to cart, check out, order, and we almost always ship out same day. We are currently out of stock on many items, but we have shipments coming in, such as the soldering station, Aten hot air station. The NF.mini pen is almost out of stock. We have a couple of them left. The grinding pens, we have about 20 pieces left. The fume extractor, not too many left. Anti-glare light, we only have 10 pieces left. And those actually ship to us by sea because they are very heavy. And it takes about 30 to 45 days to get the shipment. Microscopes, we have more than enough. Just log into the site. If it's in stock, you can order. If not, then you can either wait, or if we have the back order option, you can back order, and as soon as we get the item in stock, we will ship it to you. Like we have a lot of back orders for the Aten hot air station. As soon as we get them in, we ship out straight to the customer. We did the same when we were out of stock on the microscopes. We had the back order option, and we received a lot of back orders. As soon as we got them in, we shipped out the item same day. I would say we sold more microscopes than any company out there. We have the best quality microscopes, and you're not going to find anything like the ones that we sell. It's the same one I'm using right now. Just look at the quality on the scope. And if we go for the anti-glare light, we get a view like this. Awesome. Let's prep the fuse in the front. Now all we have to do is locate the fuses, solder them on the board, and I'm very optimistic we're gonna get this card working again. I have another donor card right next to me, not the same one, but I want to see if we're able to extract fuses off this card. Yeah, and we have a fuse right here. Let's grab it. And we're gonna put the fuse right over here. And perfect fit. Perfect fit. And now we need another fuse. The problem is I do not have this card disassembled, so I'm not gonna be able to see if we have a fuse in the front. I'm using this card, an older card, gigabyte. And we need to disassemble the card to see if we have the fuses. I do have another donor card right next to me, and can we get one from here? I do see one on the bottom on the 12-volt line, but it does not look good. I'm gonna have to grab one from another board. Let me show you the one that's on the board right now. It does not look good to me. Right there. So we cannot use this one. We're gonna have to use something else. Let me grab another cord. I have a lot of donor cords next to me. This one I believe is the 1070 or 1080 Founders Edition. And I cannot recall if we have a fuse anywhere on the board. Probably not. We have a 3080 or 3090 here. Let's check that one. And no, we do not. We do not have any that I can see. What else do we have? I mean, right now we need a fuse that will protect the 12-volt line, and not just any fuse. Let me grab more donor boards and I'll be back. Okay, so we're gonna grab one from another board. And solder it on the customer's board. Right over here. And we're good. Now, for some reason, the cable is not going in. Okay. Okay, so we have two 12-volt cables plugged in. And we're gonna plug the HDMI cable. And hope for the best. Okay, so it looks like my HDMI cable is not going in. We have a problem with the HDMI connector because the cable is not going in. Maybe it's a little bit bent. Let me see if I can fit that cable. Yeah, the HDMI connector is bent. The cable is not going in. Let's take a look and see if there's something we can do. You can tell the connector is shifted to the right. It's bent this way. It's not even on all edges. I do not have a display monitor or display cable to test right now. Okay, let me try again and see if we can fit that cable. It's not going in. Right now I'm not able to fit in the HDMI cable in any way, shape or form. We do not have a display port monitor right here, so we cannot test using a display port cable. One of the two options, actually we only have one option. We have to replace the HDMI connector, but for now I just want to know if the card is working. Maybe we can plug it in. And I want to test to make sure it's not giving 6 beeps. Because if the card is giving 6 beeps, there's something else wrong with it. It doesn't make sense to change or replace the HDMI connector if there's anything wrong with it. But if we do not hear 6 beeps, I'm gonna go ahead and replace the HDMI connector. Okay, so power on. And I do not hear 6 beeps. That's good. That's good news. The card should be working. I do have a new connector right here, but I want to make sure it will fit. A lot of video cards, they have many holes on the board, so we can fit any size HDMI connector. And if you look here, that's my connector and that's back of the board. We have holes right here, 1, 2. And if we look on the other side, we also have 1, 2. So we should be able to use this connector. Let's go ahead and desolder the old one, the broken one. And the broken one is soldered not from here, not from here, not from here. Those are extra holes. It's soldered from here, 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 and here. Without low melt solder, it's going to be very hard to remove this connector because of the thermal mass of the board. Low melt will lower the melting temperature of solder so that when we apply hot air, just a tiny bit of hot air goes a long way, and we should be able to easily remove the connector. What low melt solder does is it melts at a very low temperature. It mixes along with unleaded solder that's already on the board that melts at a high temperature, and you take the average. Now our melting point is much lower, and we can use a little bit of hot air to be able to remove the connector. And let's go to the front. And the other end already pulled out. Nice. Without low melt solder, it would have been very difficult. Low melt is magic. I always mention it. Nice. Look at the holes. Right, and we're all set. The holes are clean. We still have to clean the front pins before we solder the connector. Now let's grab our new connector. The connector may not be 100% the same, but that's why the factory, they made many holes. So this board can work with any connector. We may have to push this one just a tiny bit because the connector looks like it won't play games. Okay, very nice. As long as the pins are aligned, we should be good. I just want to apply solder to hold some pins down on the board. Very nice. And I have that cap in the way. It's bothering me. Spread the love. Because it's just better when people are connected, when they are holding hands. And that's what I'm doing to the pins. I'm making them hold hands. The end result is going to be better for all of us, right? What have you done? That's what a lot of you are saying. Just relax. Tranquilo. I want to make sure those pins are soaked with solder. We played a lot of games. Now it's time to finish up, right? Let's move that solder blob to our left, because the right side is tight. We have a big cap, a bodyguard. And now let's go ahead and make sure all the pins are solid. And they have to be. We soaked the living crap out of those pins. 2, 3, 4, 5, solid, solid, solid. Every single one is solid, perfect, awesome, amazing. We did it. All we have to do is solder the back, clean up, and test again. That's all we have to do. Very nice. Now solder flew on the hole next to it. That's okay. They are all one. We can just apply solder to everything, and not just one hole, but just for the sake of saving the world from complaints, let's just do one hole. And we're gonna do the one on top. Just like that. Now we can go over this one more time to make everything look nice and pretty. But we have a lot of time on our hands, right? A lot of time. More time than you can imagine. The only thing that we cannot do is scratch our head. That's it. Anti-glare light on. We're gonna clean up and just look at that joint. Isn't that the shiniest thing you've looked at after silver and gold. That's because we are using quality solder wire and quality flux. You can buy both from our site. Log into NorthridgeFix.com, click on shop. And I keep mentioning this for all new viewers. Old viewers, you're already customers and you already know what's going on. Just be patient with me. All right, and we're all good. The HDMI connector is soldered right here. Looks better than factory. Look at this. Look at the alignment. Awesome. It looks amazing. Maybe we can do this so you can see what I'm doing. And now we can plug our HDMI cable like this, okay, and we can turn the power supply on, and we can step on the side, and let's see if we see anything on the screen on the top. Right now we do not hear 6 beeps, but we want to see an image. Yes, right there. See it? Right there. We're done. The card is working. I'm gonna hand it over to Big Boss to reassemble and test, and he'll run it for 20-30 minutes, and we can invoice and mail this back to the customer. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.